All right, so 114 goes into 477. How many times? $477 divided by 114. It goes in 4 times, and then we just need to know the remainder. So many ways to get the remainder. One way is to just take the 477 and subtract off 114 times 4. And so I get 21. So it's 4 remainder 21. And please, 4 remainder 21. And the way Euclid's method works is the previous divisor moves up and the previous remainder moves up. So now I need to figure out what is 114 divided by 21. I get it goes in 5 times. So what is 114 take away 21 times 5? So the remainder is 9. 5 remainder 9. Next, we move up the divisor and the previous remainder. Okay, so I think I can do this without a calculator. 9 goes into 21 2 times. 2 times 9 is 18. So the remainder would be 3. And not a bad idea to check that on a calculator. Right? 9 times 2 plus 3 is 18 plus 3, which is 21. Cool, checks. And then we move up the 9, and we move up the remainder. 3 goes into 9 3 times, remainder 0. And that 0 is the key that we're done. And that means the greatest common factor of these two numbers must be 3. Sometimes Euclid's method is fast. Sometimes it's slow. But it's often more efficient than any other method for finding a greatest common factor. Now, with only 2 numbers, we can always use the greatest common factor to find the lowest common multiple if we're working with 2 numbers, because we learned earlier that the greatest common factor and the lowest common multiple split the factors. So what that means is if you're trying to find the greatest common factor of 2 numbers, let's call them A and B. Let's say that answer, we'll call that F for factor. And if you want to find the lowest common multiple of those same numbers, A and B, let's call that M for multiple. Now, the greatest common factor and the lowest common multiple share the factors of A and B, but in different ways, so there's no overlap. So what that means, because of the way we use the prime factorizations, is that whatever A times B is has to be the same thing as the greatest common factor times the lowest common multiple. So this is with 2 numbers, the greatest common factor times the lowest common multiple is always going to be the same as A times B. So what? Well, turns out that if we know A, B, and the greatest common factor, we can just divide the greatest common factor to find the LCM. So for example, in this case, I know that the greatest common factor of 477 and 114 is equal to 3. And because of this relationship right here, if I take 477 times 114, very good, try it again, there we go, and I divide by the GCF, the answer has to be the LCM. So my claim is that, again, if I take 477 times 114, divide that by the greatest common factor, the result, pretty big number, but that's what it says, 18,126 has to be the LCM. And you could use one of our other techniques. I wouldn't recommend the list method on this one. Prime factorization method might be the way to go to see that, yeah, wow, it is really the lowest common multiple. All right, so now we have several methods for finding lowest common multiple greatest common factor. I think this repeated division method Euclid came up with is pretty cool. Once you get used to it, it just takes a little bit of practice.